In this video, we're going to extend our discussion of complex numbers and talk about the multiplication, division, and powers of complex numbers. First, let's look at the multiplication of complex numbers and derive the formula. So if we have two complex numbers in trigonometric form and we multiply them together, we're going to get the following. We're going to start with r1 times the cosine of theta 1 plus I sine theta 1 times r2 times the cosine of theta 2 plus I sine of theta 2. So the first thing that we can do since we're multiplying these two numbers together is we can pull both r1 and r2 out front. Then the next thing we want to do is we want to start foiling first, outer, inner, and last. So I'm going to get cosine of theta 1 times the cosine of theta 2 plus I sine theta 2 cosine theta 1 plus I sine theta 1 cosine theta 2 plus our last term we're going to have I squared times sine theta 1 sine of theta 2. And if you remember that I squared equals -1, so I can now turn this I squared into a -1, and then I'm going to group this middle part here by pulling the I out in front. So I have r1 times r2. I'm going to pull my I out and get I times the sine of theta 2 times the cosine of theta 1 plus the sine of theta 1 times the cosine of theta 2. Then I'm going to add that to, now what I have left is this term and this term. So I have cosine theta 1 cosine theta 2, again changing that I squared into a -1, so that's going to give me negative sine theta 1 sine theta 2. Then using our sum and difference identities, as you can see I have that pulled up right here. Here's my sum and difference identities. If we look at the sine of u plus v, we get the sine of u times the cosine of v plus the cosine of u times the sine of v. So if we look back at what I have, here I have the sine of u times the cosine of v plus the sine of v times the cosine of u. So this is going to turn into the sine of theta 1 plus theta 2. Then again, looking back at our sheet, if I look at the cosine of u plus v, I get cosine u times cosine v minus sine u times sine v. So that's exactly what I have here. So that's going to turn into cosine theta 1 plus theta 2. I have my addition sign here. I have my I out in front here. And then that whole thing was multiplied by r1, r2. All right, so now that we've proved the multiplication formula, we can use that for our first example. So the first thing that we want to do is we want to figure out what is r1. Well, r1 is 5. Theta 1 is pi over 3. r2 is 2. And theta 2 is pi over 4. So using the formula that we just derived on the previous page, we have R1, which is 5, times R2, which is 2, times the cosine of theta 1, which is pi over 3, plus theta 2, which is pi over 4, plus I sine of theta 1, pi over 3, plus theta 2, pi over 4. So since we do not have a common denominator, we cannot add these two fractions together. So I'm going to come over here and get my common denominator. My common denominator is going to be 12. So I'm going to multiply both the numerator and the denominator by 4, and then multiply the numerator and denominator on this one by 3, and I'm going to get 4 pi over 12 plus 3 pi over 12, and that's going to give me 7 pi over 12. So now I have 5 times 2, which is 10, times the cosine of 7 pi over 12, plus I sine 7 pi over 12. And it says leave in trigonometric notation. This is in trigonometric notation, so I'm done. To save some time, I have already derived the formula for dividing two complex numbers, as you can see on the screen. I encourage you to pause the video and try to derive the formula for yourself. Note that from this last step down here, you need to use the sum and difference identities, just as we did in deriving the multiplication formula. And then you also need to use the Pythagorean identity in order to simplify it to this final equation right here. All right, so let's look at an example of dividing two complex numbers in trigonometric notation. Our formula on the previous slide gives us R1 divided by R2 times the cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. And note this time they want us to give our final answer in standard notation. So we're going to have R1, which is 1/2, divided by R2, which is 3/8, times the cosine of theta 1, which is 2 pi over 3, minus theta 2, which is pi over 6, plus I sine of theta 1, again 2 pi over 3, minus theta 2, pi over 6. Again, since those don't have common denominators, I'm going to come up here and find that common denominator. So we have 2 pi divided by 3 minus pi over 6. So all I need to do is multiply this one by 2 on the numerator and denominator, and I'm going to get 4 pi over 6 minus pi over 6, which gives me 3 pi over 6, which of course simplifies to just pi over 2. So now I have 1/2 divided by 3/8, which simplifies to 4/3, times the cosine of pi over 2 plus I sine of pi over 2. Now, if it wanted the answer in trigonometric notation, we would be done right here, but it says it wants it in standard notation, so we need to take this a little further. In order to get it from trigonometric notation into standard notation, I need to go to my unit circle and find out what the cosine of pi over 2 and the sine of pi over 2 is. So I'm going to have 4/3 times the cosine of pi over 2, which of course is 0, and then the sine of pi over 2, which is 1, Distributing this in, I get 4/3 times 0, which is just 0, plus 4/3 times 1, which is just 4/3 I. And of course my 0 can just go away and I'm left with 4/3 I. And this would be my final answer in standard notation. Finally, we have the powers of complex numbers. For any complex number in trigonometric notation and any natural number n, we have the following formula. Since this is a theorem, it's given without a proof, but you can always look it up online if you're interested. So now let's look at an example of using this theorem in order to solve for a complex number raised to a given power. So the first thing that we need to do is we need to write this in trigonometric notation. So we have a equals 1 and b equals 1. Again, the first thing we want to do is find r. r equals the square root of a squared, so 1 squared, plus b squared, again 1 squared, and that's going to give me the square root of 2. Then we need to find theta. So theta is the cosine of theta equals a over r. A is 1, r is root 2. But we never want to leave that radical in the denominator, so I need to multiply both the denominator and the numerator by square root of 2. And I get root 2 over 2. So my angle theta needs to equal the cosine inverse of root 2 over 2. Then I have sine theta equals b over r. b is 1, r is root 2. So again, that's going to give me root 2 over 2. So theta also has to equal the sine inverse of root 2 over 2. Going to my unit circle, I need a sine of root 2 over 2 and a cosine of root 2 over 2. And as you can see, that happens at pi over 4 or 45 degrees. So now I know that theta has to equal 45 degrees or pi over 4. So now I can write this in trigonometric notation and get r, which is root 2, times the cosine of theta, which is 45 degrees, plus I sine of theta, again 45 degrees. So here is my complex number in trigonometric form. Now that we're in trigonometric form, we can use the formula on the previous slide. And we're going to have root 2 times the cosine of 45 degrees plus I sine of 45 degrees. And we are raising that to the 9th power. So that tells me that n equals 9. Then using our formula r to the n, cosine of n times theta plus I sine of n times theta, we're going to get r, which is the square root of 2 to the 9th power times the cosine of 9 times 45 degrees plus I sine of 9 times 45 degrees. And simplifying this, we're going to get 16 square root 2 times the cosine of 405 degrees plus I sine of 405 degrees. And that is our final answer in trigonometric form in degrees. But note that we also could have written it in radians, and we would have gotten 16 square root 2 times the cosine of 9 pi over 4 plus I sine of 9 pi over 4. So always make sure that you double check what form, whether trigonometric form or standard form, they're asking you to give your final answer in. Keep in mind all of these formulas. We have the power of complex numbers, we have the division of complex numbers, and we have the multiplication of complex numbers.